wrangling with three, which are plural. Absolutely no. They are on my list of all three of them. And I want to do next. I wanted to see where might be difficult. I think going on so long.
Hello, ladies and gentlemen. So we are 5 co-hosts. We share some information. CNIC and Tsinghua University and Computer Network Information Center of Chinese Academic Science, China Communication Standard Association, Internet Society of China. We build the foundation of the internet together. Collaboration for the development of two standards. So together we work to make the internet better. Why we here? Because CNIC is originated from Chinese academic science. So Tsinghua University and Chinese academic science and Peking University built the first internet of China. So invention of internet. So CCSA, we also build a lot of IETF standards. CCSA help some Chinese IETF standards deployed in China. China Internet Society so also help together to encourage more young generation to join IETF work. So this is our aim, maybe, or proposal. So here now we share my slide. So everyone have maybe I can give a timer. Everyone 8 minutes. So first we give some introduction about CNIC. CNIC is CCTLD registry .cn. We also the Chinese version also have GTLD. Our 公司网络 company and network. Also, we are national data IP address center. We also do some survey, also do some research. CNIC currently has 300 staff, but for this IETF meeting, we around 50 staff fly from Beijing to here to support the IETF meeting. So just to make the IETF meeting run better. Sorry. So we call our research as Internet Infrastructure Resource Layer Research, naming DNS, addressing IP address, also routing BGP. Also, we can relate work. Also do some survey. For example, how many population in China already get online. Now already more than 1 billion internet users in China. This is a key technology and a platform in CNIC. So we have 2 core platforms. Global DS service platform of CCTLD, big data platform for internet infrastructure resources, and DS resolution products, DS business management system. Also, we have think tank or give some proposal or some policy related research. We have 6 key technology: DS protocol and architectures, big data analysis, DS software and hardware products, network identifier and future networks. DS security systems, internet routing system. So we have an architecture of internet infrastructure resources service. So currently we have, Tsinghua is mainly related to domain names and DS. So we some, any system is related to domain name and IP address. So we also have a national engineering laboratory for internet domain name management technology. We currently have 3 major directions: key technology for internet fundamental resources, internet industry development and governance, innovation technology for internet fundamental resources. Here is also key technologies. So we also reflection on the innovation development of internet infrastructure resources. We also have standards. Currently, I mainly work involve IETF standards, email, domain name, DNS, IDN related. We also platform software. Also, we have will have a satellite internet. Also, some now have a AI related technology. So we also do some research. In Tsinghua, half of Tsinghua staff are related to technology work. Also, half of them have a technical background. So now we have in DS in AI area, as the internet and the AI area, DS is also ready to play an active strategic role in understanding intelligence-driven application and service. So because DS is important in this area, in current internet, I think in future with internet of AI agent, I hope DS still play key role in internet of AI agents. So we have also have some products use AI empowered service system for internet infrastructure resources. So every product, every service, every software, we make some AI ready. We try to make adapt to the AI. So with the agent DS, we have my view, traditional app and a website. We use domain name for addressing, rely on domain name, system for access, domain name SOS. So what's the difference of traditional app or traditional website and AI agent? We can regard the AI agent as a new app or super website. So from this kind, there are no big difference. Just the AI agent is more clever or more intelligent than the current app or website. So they still need naming and locating. So because they are still based on current TCP/IP protocol or current internet protocol. So naming for AI agent still, I might think is still DS will still play key roles. So AI agents require domain names, just like a traditional app on a website. So AI agent, I think IETF will still play key roles. So in this IETF meeting, Monday we have Monday morning we have a side meeting, interconnecting and the discovery of AI agents on the internet. From these discussions, many experts share their views. One thing I think many experts agree, DS still keep an important role in naming, but the discovery may also maybe need even more technology or new technology. But naming because is important DS, I think we can play a very important role in the future naming system of agent DS. So in China, we also have discussion with many experts or many organizations and many companies. We have this discussion. Also, AI is a DS agent or AI related technology is a very hot topic in some universities. For example, in Tsinghua University, some students, if the supervisor, no AI related, I will change the supervisor or change to another area. So AI is very, very important. All students folks are interested in it. So agent DS also we have a testing or implementation or platform. There we also have current prototype hackathon. So thank you. So next speaker is from Professor Cui.
Thank you. So where's my slides? So anyway, so welcome to this large meeting and also welcome to this IETF meeting in China. This is Yong Cui from Tsinghua University. So here, okay, we got my slides.
Yes.
So I will say something about Tsinghua University at IETF from solving the problem to shaping the internet standards. And this is the outline. I would like to go through this why Tsinghua at IETF. As you may know, we run 3 networks. The largest education and research network in the world. The CERNET-1, we have around 20 million users in this CERNET-1 in IPv4, and also we run the second one, version 2 in IPv6, and also the future internet backbone in as CERNET-3. So when we run the network, we find the real problems to solve, and then we go to the academic research to see what is the problem and what is the innovation. When we make a lot of breakthrough ideas, we also have the very first the ranking in the CS ranking. So this year in CS ranking, our Tsinghua University ranked the very first on the field of computer networks. And we also developed the call routers and the subsystem even equipment. For example, the first IPv6 call routers in China. And we also apply this equipment and the systems in our network. And when we make through this circle, we find IETF is the right place to enlarge or improve our innovation into the real world to get the impact. So we came to IETF in 20 years ago, more than 20 years ago. So what problem we have to solve here? We focus on the internet architecture, especially on the sealability and also security. For example, how to use IPv6 for our scalable internet, especially for the seamless IPv4, IPv6 global coexistence. And for the security, we also looking for the fundamental security issues like eliminating IP spoofing from the access network even to the backbone routings. So here the scalability, especially on IPv4, IPv6 coexistence. So we initiated the software working group for tunneling transition from IPv4 to IPv6, especially on the 4 over 6 technologies. And additionally, we also contribute a lot in Behave working group for the transitions, namely for IVI, if you know IVI. IV it means 4 and VI means 6, so IVI. And also for the security part, we especially focus on the source address validation. When we came to IETF in the very early, we hope to solve this problem as architecture. And after the feedback from IETF, we make some kind of improvement, namely SAVI, as SAV improvement working group. We formed this working group more than 10 years ago and standardized the access network mechanism. And also recently, we've also formed another working group named the subnet for the intra-domain and the inter-domain networks for source address validation. And especially, we also look for some application issues like low latency. We start BOF for the internet storage synchronization for the cloud storage service, and also work on the interconnectivity for the agent communications and some manageability issues, especially for the large-scale model for agent networking, and including protocol testing, network management, and the DDoS attack defense. So here we get how this effort became our community impact. So Tsinghua University contributed more than 20 RFCs, placing it the third in China. And actually, we also lead different institutions in China to IETF. We hosted the first IETF conference in China, that is 16 years ago in Beijing, and maybe some of you have been to Beijing for this IETF meeting, right? And also some of our professors got the receipt from different things, like Professor Jianping Wu has received the Jonathan Post Service Award, and both Professor Jianping Wu and Professor Xing Li have been inducted into the Internet Hall of Fame. And Professor Xing Li was also the first IAB member in China. Actually, from the experience of more than 20 years in IETF, when I personally came to IETF meeting from time to time back to 2005, there were only 5 guys from China mainland, including me and Jiankang Yao in that time. Now there are more than several hundred people from China to IETF, right? And this is a very good improvement. And what we have learned in IETF, especially as a university, I would like to give special thanks to IETF. Someone said this is the beautiful heaven for the technical contribution to the internet. I'm not sure if you all agree, but we believe so. And here, top expert provide the detailed guidance to our newcomer student, and that's a very good environment. And when we provide some issues to IETF, like the registration cost is pretty high, especially for the student. And then IETF give the quick response to have a low student registration rate. And this time, we also have the IETF talent program. That's very good. And we also have some challenge here. For example, how to make the short-term visible result to the student, especially for 2-year or 3-year student. So we hope to have flexible and quick achievement, especially for the student. Maybe this is an issue for IETF to solve if you hope to have this kind of newcomers as a student. And so hope to cooperate with every one of you. Thank you. Thank you.
Good afternoon, everyone. A very warm welcome to Shenzhen. I'm Yan Biaoli from the Computer Network Information Center, Chinese Academy of Sciences. We are honored to co-host this IETF meeting. One topic in today's panel is industry-academia integration. I'd like to share some of our perspectives and practices under the theme, driving IT innovation with advanced information technology. Here, while the word IT commonly refers to information technology broadly, in our context, it relates most closely to the evolution and application of Internet technologies. About 32 years ago, a full function link was established between the NSFNet and the Chinese Network and Computing Facility. This marked China's entry as the 77th country connected to the global Internet. Notably, this historic access point was located at the very site where the CNIC was founded. Then we developed the first router in China and deployed China's first .cn domain name server. CNIC runs a national backbone network called CSTNet. It connects all the institutes in Chinese Academy of Sciences and more than 80% national research infrastructures in China. CSTNet operates its own international exports, providing network services primarily to support international scientific research collaboration. Actually, unlike most research institutes, we have dual roles across academia and industry. As an institute of Chinese Academy of Sciences, our core mission is to advance science through pioneering research and innovation. Simultaneously, as the operator of national scientific IT infrastructures, our parallel mission is to develop and deploy reliable systems, delivering high-quality network and computing services. This dual role is significantly broadened the origin of our research problems, drawing from both curiosity-driven exploration and practical necessity. However, this leads us to a fundamental question. How can we ensure that research innovations are engineering ready and can be effectively translated into operational services? Our approach to bridging the gap is a hybrid virtual physical evaluation platform. It connects three core elements: the cloud network emulator, multiple experimental network slices on CSTNet, and a global cross-network testbed. The platform is built on a suite of advanced IT technologies, including FlexE, eVPN, SRv6, and lightweight virtualization, to name only a few. Here is a typical workflow with this platform. It begins with a research problem. After completing an innovative solution design, the evaluation process proceeds as follows. The design is first tested and assessed via a large-scale cloud network emulation, and is then implemented on hardware devices for hardware-in-the-loop verification and evaluation. Next, it is deployed on selected experimental network slices for system-level validation and evaluation. Once all these stages are passed successfully, the solution can be deployed into the production network for real-world applications. Meanwhile, issues identified in operational systems are collected and analyzed, directly informing the next iteration and closing the feedback loop. Here is an example of problem-driven research. 2 years ago, while planning the deployment of RPI ROV in CSTNet, we conducted a comprehensive evaluation of existing implementations. Then we identified a common performance issue: the validation speed is inversely proportional to the number of valid routes. Through in-depth analysis, we traced this issue to the validation model itself. IFC 6811 explicitly defines a cover first then match model, which can quickly output a not found status, but delays the processing of valid routes. This design made sense in the early days of RPKI, when very few BGP routes were covered by the route origin authorizations. Today, however, over 60% of BGP routes are covered, and this number continues to grow. In light of this, we propose a new match first, then cover model that can output the valid status at the earliest possible stage. Then we instantiated this model and the hierarchical hashing scheme, accelerating LV multiple times with performance that improves alongside RPKI coverage. The solution was implemented in software routers and validated on our cross-network evaluation platform. A powerful evaluation platform can also empower the exploration of new research frontiers. Here are two examples. In this first case, our platform fosters innovation in multi-agent systems. For automating routing security operations, a general LLM-based commander agent interprets requests and coordinates specialized agents, which collaboratively execute tasks ranging from BGP anomaly detection to root cause localization. These agents are deployed on our evaluation platform, where they learn from evaluation results to automatically adjust their policies. Okay. In StatNet network research and development, a powerful emulator is invaluable, as deploying and evaluating innovations on real satellites is very difficult and costly. Our platform can construct a virtual satellite network with tens of thousands of nodes within minutes, reconfigure thousands of virtual links in milliseconds during runtime, and support hardware-in-the-loop testing. Building on this foundation, we have started various of constellation architectures and developed a suite of new protocols. Okay, my stop here. Thank you.
You save some time.
Okay, thank you. This is Zhao Shizhuo from CCSA. Today I'm very glad to be here to share some information about CCSA and the relationship between CCSA standards and IETF standards. My slides consist two main parts. The first is introduction of CCSA, including the membership, organizational structure, standards, and also about the activity dates from the last year. And the second part is the introduction about the relationship between CCSA standards and IETF standards, as well as IPv6 standards in China. These slides, you can see that the CCSA membership increased from 2002. In that year, CCSA was established. The membership have grown from 109 to 1,200 last year, representing about 11-fold increase. This chart shows the membership composition. Among CCSA members, the manufacturers account for the largest share at about 40%, followed by the internet service provider at 20%, and then the R&D research institutes, as well as the universities. In recent years, the number of members from vertical industries such as finance, home appliance, and the automotive have been increasing year by year. This chart shows the organizational structure of CCSA. At the top is the General Assembly, followed by the Council. The General Assembly is the highest authority of CCSA. Under the board, also another name is Council. We have the Technical Management Committee, technical committees, and special task groups, and the standards promoting committees, and the Secretariat. Currently, we have totally 13 technical committees. Technical committees is the main technical body in CCSA. And these technical committees covered nearly all the communication fields, including the fiber communication, mobile communication, security, and also, of course, the internet standards. Under each technical committees, we have several working groups which carry out the specific standards development according to their respective fields. In addition to the technical committees, we also have several special task groups and special product groups, which are more flexible and time sensitive in terms of the establishment and the dissolution. This slide shows all the standard promoting committees. The main purpose of the standard promoting committee is to be responsible for the promotion of standards and the research, the pre-research of standards, including the conformance testing and experimental verification. They mainly cover the emerging and the converged technology fields, such as finance, healthcare, and smart home, and other sectors. This chart shows the number of standards that developed by CCSA over the years. The standards adopted by CCSA follow into the three categories. You can see the three different colors. The first one is national standards. Is issued by the SAC, the government, and also the industry standards issued by the MIT, also the government. The third category is the CCSA standards issued by CCSA itself. You can see that the green part is CCSA standards. In recent years, we have issued about 600 to 700 standards annually. And the industry standards still account for the largest part, while the number of the CCSA standards have been increasing year by year. This slide shows the CCSA's activity state for the last year. We have about 1,200 members through the year, and we have about 500 standard meetings, and also we have about 3,000 ongoing projects. In the past 2 years, to improve the efficiency of standards development, CCSA have shortened the standards development cycle from 2 years to 1 year. This means that we will need further increase the number of standard meetings in the future. Okay, next, I would like to give a brief introduction to the collaboration between CCSA and IETF standards. As a leading standards organization in China, CCSA pays much more importance to the global collaboration, and we cooperate with the IETF on the standards adoption. First one, our work focuses on 3 areas. The first is we actively adopt and transform mature IETF standards. Second, we carry out the customized R&D, closely aligned with the actual needs of domestic industries. The third one is on this basis, we have established a comprehensive standard system that follows international trends while supporting domestic development. As you can see that many of our technical committees, including the Internet Appliance Network Capabilities, Network Management, and Network Security are closely aligned with IETF core technical areas. We jointly promote the development of relevant technical standards. Finally, let's look at about the IPv6 standards in China. To promote this initiative, CCSA established a dedicated IPv6 standards working group in 2021. This working group focused on the 5 core areas: innovative technologies, address management, monitoring and evaluation, industry appliance, and security protection. To date, we have successfully issued 38 national standards. And looking ahead, we are also actively planning for the future and have launched the development of a second batch of 13 national standards, aiming to further improve our standard system to meet the demands for IPv6 technology development. Okay, that's all my introduction. Thank you so much. I'm looking forward for the close collaboration between CCSA and IETF. Thank you so much.
Okay, distinguished experts and colleagues, good afternoon. Hi, I'm David from the Internet Society of China and the Deputy Secretary General. First, it's a great pleasure to share the ISC practices in promoting young engineers' participation in the IETF and international internet standardization. And today I will focus on how can we help young engineers move from learning about the IETF to actively contributing and growing within it. And the importance of the IETF is not only in technical influences, but also in its open and community-driven model and enabling young engineers to understand IETF, engage with its community, and participate in international standardization is both meaningful and practical. Okay, please give me 1 minute to introduce the Internet Society of China. ISC, founded on May 25th, 2001, is a non-profit social organization in China's internet industry. And ISC co-host IETF 79 in Beijing, China, 2010. So ISC committed to promoting internet technology innovation and industrial cooperation and international exchanges, and built an extensive platform connecting with industry and academia and research communities in China and beyond. We believe that supporting young technical talent to engage in global internet governance and standardization is crucial for individual growth and for the long-term development of the technical community. So last year, we together with CNIC and Tsinghua University, CCSA, Huawei, and ZTE jointly launched the IETF Talent Development Program to support young scholars in participating in international internet standardization and help young engineers understand IETF mechanisms and follow technical discussions and gradually participate in standardization through continuous learning and practice. And this time, there are 59 students participated in the program, including 13 normal and 46 new. So this new step.
And from our experience, young engineers usually go through 4 stages of development in the IETF. The first one is learn, and the second one is engage, and the third stage is practice, and for the fourth stage is contribute continuously. And ISC has explored several practical approaches. First is technical exchange platforms, such as we provide engineers with opportunities to communicate and share experiences and learn from each other. And the second, we such as training activities and some workshops, and help young engineers become familiar with IETF processes and discussion methods and international standardization practices. And the last one is such as international conferences and exchanges. Encourage participation to gain first-hand experience and improve the ability to engage in global technical collaboration. And through these efforts, we hope to form a practical talent development pathway to learn and to engage and to practice, and the last, to contribute. And as we all know, there are still several challenges remain, such as participation cost. So we have to buy the ticket to participate in the IETF meetings, and the knowledge gap. Many young engineers are still not fully familiar with IETF processes and community culture. The last one is such as inconsistent support is very important, because support from organizations in terms of time and resources and long-term encouragement is sometimes limited. So looking ahead, we believe processes can be made in 4 areas. And first one is systematic talent cultivation, and the second one is collaboration across organizations and open and inclusive technical community. And the last one is institutional and resource support. So there are still have some process to make. And ISC will continue to serve as a bridge and a platform, and actively promoting technical exchange and international cooperation, and helping create a supportive environment for young engineers. And we also look forward to strengthening exchanges and collaboration with all stakeholders, such as some multi-stakeholders, and combined experts and the universities and enterprises and some colleagues, to enable the next generation of engineering to contribute to the global internet community. So just as IETC is a non-profit organization in China, internet field. So we just it's a bridge and a platform to combine all kinds of resources and all kinds of organizations, such as enterprises and universities and some research communities, as we work together to improve the participation for the young engineers to participate in the IETF, especially for the international standardization. So I think it's because we have worked together and make some more cooperations in the future, and to make a better future for the young engineers to participate in international standardization is a very great step, but still is a long way to go. But we have make a step. Thank you. It's my speech. Thank you.
Now is open for questions. So any question you can ask the panelist. Thank you.
Hi, sorry, I forgot to sign in. I'm just struggling to find it here. I'm Rod Van Meter from Tsinghua University. I'll get signed in here in a second. One of you was talking about the relationship between CCSA and IETF right there at the end. Can you say a little bit more about how standards for communications in China actually work? Are you allowed to use systems? So the IETF standards, you don't have the force of law, right? But in order to be used in China, do they have to be ratified by CCSA and have the force of law in some sense?
Okay, thank you so much for your question. From the perspective of CCSA, we all pay much importance to the close collaboration between CCSA and the other international or regional standards organizations. Of course, IETF is a very important partner for CCSA. In recent years, we have established a communication channel. We visited and participated in IETF meetings, and in technical area for CCSA, we also adopt some of IETF RFCs. And also, when CCSA develops or published CCSA standards or industry standards, we also encourage our members to contribute the mature text or mature standards to IETF, bring it to IETF to promote the RFCs, related RFCs to be published by IETF. Thank you.
What about the relationship between CCSA and ITUT? Does China actually recognize the ITUT standards directly, or do they have to be further ratified inside of China?
You know that ITUT is a governmental organization.
Right.
CCSA supports the government of China, the MIT, to participate in ITU's activities. And also we adopt ITUT standards directly from ITUT recommendations. I think there's a large number of ITUT standards was adopted by CCSA, translated to CCSA standards or industry standards.
Thanks.
Thank you.
May I just add some more comment? So between IETF and CCSA, I also one expert of CCSA. So actually, most IETF, CCSA related IP standards, we just follow IETF standards. So when IETF products are say ready, so we will help publish or make it to be implemented or published as CCSA standards. So if someone try to invent some new, we just say you first it should promote into the RFC, then return to back as CCSA standard. So no conflicts, harmonious. So we work together to make internet better.
Question for CCSA. I was wondering if you guys have been thinking about how to use AI as a tool in standards development, whether it's something mundane like taking minutes, or what role you see playing in innovation. So basically, or like language barriers or things like that. So essentially, how are you thinking about AI and its role in the development of new standards? Thank you.
Thank you so much. In terms of AI, I think it can fall into two parts. Or the first one is how to develop standards on AI. and also how to use AI as a tool for the development of standards. For CCSA, we have developed some CCSA standards or report on AI, and also we are now developing a model. How to say that? An AI model, a dedicated AI model to review the draft standards, and also to translate the Chinese from Chinese to English. This big model is expected to be issued maybe in the end of this month. We hope it will help to improve the efficiency of the standards development in CCSA. Thank you.
Thanks for an interesting overview. I'm curious as to whether any of the industry-developed standards that you have locally in China, you expect to also send forward to the IETF, and what areas do these standards come from that are not covered elsewhere internationally?
Yes, we encourage our members or Chinese talents to contribute CCSA standards or industry standards to IETF community. In terms of the technical areas, I'm not so sure. Maybe I cannot give you the exact answer. Maybe the others experts can answer this question.
Actually, I have another question here. Maybe 10 years ago, we also work 406, something like IPv6, IPv4 transition technologies in CCSA, and when we get some improvement, and we also discuss these issues in IETF. And in that age, I think there are different discussions both in IETF and in CCSA, and we push the technical standards both in IETF and CCSA. So my question is, for the aspect of IETF, do we welcome CCSA standards to IETF? Or maybe not only CCSA, maybe some other areas, some other countries, the standard from other countries to IETF, do we welcome them? I'm not sure. This is a good place to ask this question.
Hi, my name is George Giannis. I'm from Hawaii. Thanks very much for the interesting presentations. Regarding the technology development program, you know, that we stimulate newcomers to come to IETF. Are you planning to continue this program for a long time? This talent program, development program.
Yeah.
So, glad to meet you to answer the question. So the talent program in IETF, we co-host by the such as CNIC and the CCSA and Huawei and the Tsinghua University and the ZTE. So we launched last year, and this time there are nearly 60 students participate the program, and including 13 newcomers and some 46 normal participate. It's a great step, we think, because we scholars for the, especially for the students in the university. Maybe I think I can, Mr. Cui can answer the question.
Yeah. Actually, one of my students also got this talent support. I think this work organized very well, not only for the payment, the cost, and there are also some organizations for the student to get involved in in IETF activities. So I really hope to get maybe hope IETF can continue this kind of activity, but this will be determined by IETF and maybe in the next host if we go to July. Thank you.
Okay, thanks.
By the way, thank you IETF ILC choose Shenzhen as the venue, so our younger students can have an opportunity to join the meeting on site. Thank you very much.
Yeah, hi, Charles Eckel. Just thank you very much for hosting us here and for this presentation. I was also really impressed by what you're doing to encourage newcomers and students, making it easier for them to participate in IETF. I'm wondering if you're already familiar with the IETF hackathon. It happens on the weekend at the start of the IETF meeting. And I think we found that to be a really good way for newcomers to engage in the IETF, to work on running code associated with the standards we're developing. So one, I was just wondering if you already were aware of it, and if some of your new participants and students are already participating in it, and if so, if you have any feedback from them, or if you've heard anything about how it's working for them, or if there's something we could do to improve that for them in the future.
Okay, thank you. So currently, according my thinking, or according to the feedback I received, the hackathon is very, very excellent. The students newcomers are very happy about it. Thank you very much. We will try to maybe encourage them to join the future IETF meeting. Thank you.
All right, thank you.
Thank you again. I have one more question, and this has been very engaging. What do you think can be done better from your perspective to improve like the international standardization and cooperation? Or the flip side of it is, what do you think are challenges as we look to the next 5 years out?
Challenges, I think, my view.
Just a personal view, because currently the geopolitical issue is very complex, but happily our technical community, IETF community, focus on technology. If we work together, we will make the internet better. Even the world is changing, but we should still keep the internet and make it better. I heard Winsor said, one world, one internet. We should achieve it. How hard to achieve, but we should try our best to make it better. Thank you. So one last question. We will stop at 4:45. If no more any comments, maybe everyone can say last word.
Okay, thank you for to participate the IETF because I think we can just Mr. Yao Jiankang said we will have a better future because one world and one internet, so we are equal and we can just enjoy the information from the internet and from the future, especially such as some disabilities. So we will do something more for the world. Is our duties. Thank you.
Thank you so much. I would like to add some information about the question about that lady have asked. I think another challenge is AI. I think AI is approaching, and now we are facing AI era. So how to develop standards with AI, or how to develop standards rated on AI. So this is a challenge for us. CCSA have done some work on this area. So we are very pleased to close collaborate with IETF to face this challenge. Thank you.
And also welcome to China, welcome to Shenzhen, and also welcome to Beijing. If you think our IETF community should have some kind of research, and Tsinghua University is also ready to collaborate with all of you and to make our internet better. Thank you.
Okay, thank you. Welcome to Beijing again. And I hope that the IETF can make something to bridge the gap between the academia and the industrial, like wide standards, and encourage more newcomers from the academia to join the IETF community. Thank you.
So maybe we just this slogan. Together we work to make IETF and the internet better. So the meeting is concluded. Thank you.可以，全都是你的。